Now let's take a look at the BIOS setup on an actual PC. I have a system set up over here. First thing I'm going to do is I'm going to turn it on and allow it to go through the setup, and I'll try to comment on what happens during the power on self-test and the other parts of the system booting. And then we're going to reboot the system and try to pause it so I can show you what's happening during these different portions of the boot sequence. All right, I'm going to turn the system on. And on the screen, you're going to see the sign-on message from the video card as the system scans the slots and finds the video card ROM. Now it's going through the power on self-test. And then, at this point, it would be loading the operating system. So it's very fast. In fact, most newer systems go from power on to loading the operating system in less than 7 seconds. That's actually a part of the PC 2001 standard, which is set forth by Intel and Microsoft Corporation to have a fast booting system. They've created a series of standards, and one portion of the standard is that the PC has to boot in less than 7 seconds. That Intel calls that rapid BIOS boot, but it's part of pretty much all newer systems. Now, the only drawback to this rapid booting is that you get very little time to hit the appropriate key to go into the BIOS setup. Now, during that, from the moment I turned it on to the 7 seconds, which elapsed and then it started loading the operating system, at the bottom of the screen, for a brief instant, appeared the message, press F2 to run setup, which is the key in this particular system to run the BIOS setup. Now, this keystroke sequence to enter your BIOS setup will vary from board to board. In my book, Upgrading and Repairing PCs, I list all of the various keystrokes for many of the different motherboard BIOS, but you'll usually find that in the documentation for your motherboard. Most of them are hitting the F2 key, some are hitting the F1 key, on some you have to hit the insert or delete key. It really depends upon what system you have. Now, what I'm going to do is turn the system off. I'm going to power it back on, and then I'm going to try to pause these various screens or portions of the boot sequence so we can see them more clearly. I'm going to turn the system off. I'm going to power it back on. And to pause it, I'm going to hit the pause key on the keyboard. Okay, I've just paused it now, and you can see we have an NVIDIA GeForce 2 video card, and the message that's in the upper left-hand corner of the screen is actually from the ROM on that card. It's a copyright message. Most of the card-based ROMs will have a copyright message that you'll see. And it's showing me that that card also has 32 megabytes of RAM on it. It gives me the version of the BIOS that's on that card. Now, to change that would require either installing a new chip or reflashing the BIOS that's on the card itself. This is not a part of the motherboard. This is actually from the video card. Now, when I unpause it, it's going to continue with the power on self-test, and I'll see if I can freeze it again very quickly. And I'm going to unpause. And I missed it. I'm going to have to try that again. I'm going to restart the system. It's only on the screen for about less than a second, so we'll see if I can catch it this time. Okay. At this point, I've frozen the screen, and you can see the power on self-test here. It's giving me the Intel copyright message. This is because this happens to be an Intel manufactured motherboard, and we're using their BIOS on the motherboard. And it's identifying the processor and speed. In this case, it's a Pentium 4, 1.7 gigahertz, 128 megabytes of RAM. It's identified the hard drive, and then right after that point is where I paused it. So there were a few more things that were going to appear here, but I've literally frozen the system. Now, to do this, again, I'm hitting the pause key on the keyboard. To unfreeze it, I'm just hitting the space bar. Now, look at the bottom of the screen. You can see the message where it says hit F2 if you want to run setup. So that's the prompt that on this system you want to get into that BIOS setup. So if I unpause it now, it's going to continue, and I'll see if I can pause it again, and we'll see a little bit more. I'm going to unpause, and I've frozen it again. Now notice the F2 message is cleared, pretty much meaning that the opportunity to run the BIOS setup has expired. If you didn't hit the key by now, it's too late. So a lot of times you have to be hitting that key almost as you power the system on. And this is an LCD display that has an instantaneous warm-up. If you have a CRT monitor that takes 20 or 30 seconds to warm up, the modern systems will boot so fast the monitor won't even be warmed up by the time that all of this is flashed by on the screen and you've missed it all. So a lot of times with newer systems, what I'll do is turn it on. I'll just count to 2 or 3 and then start tapping the appropriate key to run the BIOS setup. Unfortunately, then you won't always get to see the prompt. But Anyway, now you can see some other portions of the test are showing up on the screen. I'm going to unpause it again. And at that point, it finished the power on self-test. That was the beep you heard. It always beeps when it finishes the post. And then at this point, it would be loading the operating system. I just have the bare minimum OS on here, just the kernel files for Windows 98, so we wouldn't have a lengthy operating system boot at this point. Anyway, now I'm going to restart the system again, and this time I'm going to hit the F2 key when it says, and then we're going to go into the BIOS setup. So I'm going to restart the machine with Control-Alt-Delete. I'm going to get ready to hit F2. So I have a very brief time window to hit it. And there, I hit the F2 key as the prompt appeared, and now we're in the actual BIOS setup. Now you can see we've basically got a series of menus and that are on the screen. Now at this point, I usually like to ask my class, we're looking at this menu. We're obviously running a program. Where did this program come from? Where is this program in the system right now? Well, I can eliminate several things. Number one, this program has not been loaded from the hard disk. In fact, this entire setup procedure will work even if there is no hard drive connected to the system. So this program did not load from a hard drive. We can eliminate that. Number two, it is not stored in RAM, because this program will run from a power on with no drive, and the only way software can get into this is if a hard drive was loaded in the system. So this is not loaded into RAM. In fact, this program comes from the ROM, the motherboard ROM BIOS. So I can see various choices here. I've got a main menu, an advanced menu, security, power, boot, and exit. And then within each of these menus, there are a number of choices for configuring different items in the system. Now, let me go to one of the choices here. Let me go to, I'm going to go to the peripheral configuration menu, hit enter, and we've got various items here which we could change. For example, I could change the configuration of serial port A or B. I'm going to hit escape to back up. I can go to the IDE configuration menu, the floppy drive configuration menu. Let's say I go to the floppy configuration menu, go down to where it says floppy A, and by using the plus key, I can change to the different types of drives that the system will accept. If I hit enter, usually it'll come up with a menu listing all of the choices. I'm going to select the 1.44 MB 3.5 inch, which is the most common type of floppy drive. And if I select that, you can see that the change has been made. Now the change has not yet been saved, though. If I hit escape, in order to save that change, I would have to go here, exit saving changes. Now at this point, I want to ask another question. Assuming I select this option, where is this information saved? Now that's an interesting question. Is it saved to the hard drive? No, because this works without a drive even being installed in the system. Is it saved to the ROM? Can't be saved to a ROM chip. ROM chips are read-only. You can't write data to the ROM. Is it saved to the RAM? Can't be saved to RAM, because if it was saved here, the moment I turn the power off, it would be lost by the next time I turn the system back on. So this brings us to a whole new element in the system. It's something that most people call the CMOS RAM. CMOS stands for complementary metal oxide semiconductor, and actually it's kind of a misnomer because that term refers to the materials and the process in making a chip. In fact, virtually all modern chips are made using one or more variations of the CMOS process. That includes processors, motherboard chipsets, ROM chips, etc. But back in the early 80s, when IBM first designed the PC, there was only one CMOS manufactured chip on the motherboard, and that was a special type of memory chip that is normally called by the manufacturers anyway an NVRAM chip. NVRAM stands for non-volatile RAM. Now that's kind of a strange one because RAM is volatile. How can you have non-volatile RAM? Now let's go over to this board here. On this motherboard, we already talked about the motherboard ROM, which is the AMI BIOS right here. We mentioned the battery before, but we said that the battery was not connected to the ROM. Now you've already seen the BIOS setup program. The BIOS setup program is stored in this ROM chip, or the ROM chip on whatever motherboard you're using. the settings that you see and can change. Now those cannot be stored in this chip because this chip is read-only. They're not stored in RAM because RAM is volatile. They're not stored on the hard disk because this whole process works without a hard disk even being installed in the system. That brings us to this chip right here. If you look at this chip, it has the letters SEC on it. Now anytime you look at a chip and you see something like that, that's the manufacturer logo for who made this chip. Now a lot of different companies make this type of chip. This one happens to be made by Samsung Electric Corporation. Now the part number on this chip, if you called Samsung, they would tell you this is an NVRAM/RTC chip. NV meaning non-volatile RAM / real-time clock chip. This is what most people call the CMOS RAM chip. This is where your settings and configurations that you make in the BIOS setup menus are stored. And it is this chip that is powered by the battery here. Now these RAM chips are designed to run on very little power. Most of the so-called CMOS RAM chips in modern PCs run on about 1/1,000,000th of an amp current. That means a little coin lithium battery like this, which is a model 2032 lithium battery. You can pick these up for $1 or $2 at most drugstores, Radio Shack, etc. This battery can power this chip for anywhere from 2 to 5 years. But, of course, being that that battery is much like any other battery, one day that battery will expire, and when it does, the data in this so-called non-volatile RAM chip will, of course, disappear. So although they call it a non-volatile RAM chip, what they really mean is it's a special type of memory chip that runs on very little power, enough such that it can be powered by a battery like this for 2 to 5 years. Now, once that battery dies, you'll know that it's dying by losing time. The system will appear to run slow. The clock that is in the system will run slow. You'll lose hours, minutes, hours, days, weeks, etc. If you start to see that happen, that's a good time to replace the battery. Or if something like 2 to 5 years have gone by and you haven't yet had any problems, you might consider replacing the battery anyway as a form of preventive maintenance. Anyway, all of the settings that you change in those setup screens, those are stored in that CMOS chip. So now we kind of have, you can see all of these things working together. The setup menus are stored in the motherboard ROM, and when the setup program is run, it reads the settings out of the CMOS RAM chip and then allows you to make changes. And when you make changes, you save those back into the CMOS RAM chip, and that chip is powered by this battery for 2 to 5 years. Now in a modern PC, the battery is not used unless the system is unplugged. That means as long as the system is unplugged, even if it's turned off, the battery is not used. It is possible, therefore, to change the battery with the system plugged in and not lose any of the settings. I don't know if I recommend that because it's usually not a good idea to work on a system with it being plugged in, but it is possible. In any case, if you are going to change the battery, it's a good idea to go into the BIOS setup screens and write down some of the important settings. To me, mostly that means the settings concerned with the hard drive. Most of the other settings aren't that important. That is, if they get changed or they change back to defaults, it's not going to cause a problem. But if the hard drive settings change, you may not be able to reboot the system, and you may not have access to your data. So I highly recommend you go to your hard drive configuration screens in the BIOS setup and write down anything that's there so that after the battery is changed, you can put it back to those settings. Now, most of the time, they'll be at an automatic setting, in which case you won't have too much of a problem. I'm going to show that back over on this system here. Now here we are at the in the BIOS setup screens. I'm going to go back over to the advanced menu, and as I scroll down these different settings, you can see right here where we get to IDE configuration. This is the screen which has to do with the hard drive settings and configuration. If I hit enter here, this controls the IDE controller on the motherboard, and then over here we have settings for our primary and secondary IDE devices. We have a master and a slave on both the primary and secondary. Now I currently only have one drive actually installed in this PC right now, and that would be this Western Digital hard disk right here. If I hit enter on primary master, it brings me to the settings screen for this particular drive. And you can see that it's set to auto. Now by setting this to auto, all of the other settings are grayed out. By grayed out, that means I can see them, but I can't change them. If I were to change the setting from auto to user, meaning user defined, I can now scroll down to many of these other settings and change them. Now, in most cases, I recommend you don't use the user defined option and instead use the auto option. What auto will do is allow the motherboard ROM to read the settings off of the drive and make the appropriate choices automatically. I mean, it eliminates you having to know a lot about the hard disk you're installing. So in almost all cases, I do recommend setting it to auto. Let's take a look at some of the other BIOS setup screens and see what type of settings we can make as well. We already looked at the floppy drive configuration screen here. Let's take a look at some of the other important ones. PCI configuration. This has to do with the PCI slots. In almost all cases, you'll have the so-called interrupt request priority routing set to automatic. This is something that usually we don't make any changes for. The only time you would probably change this is if you were using an older non-plug-and-play operating system, such as Windows NT or even DOS with a system like this. But most people wouldn't be using an operating system that old. If I go here to boot configuration, these screens allow me to make settings, for example, here plug-and-play operating system. If you're using Windows 2000, Windows XP, or Windows 95, 98 ME, this should be set to yes, because those are all plug-and-play operating systems. What this does is allows the operating system to make resource changes on the system without having the system be involved in that also. If you change this to no, that means you are not using a plug-and-play operating system, and that allows the motherboard to make all the resource changes to eliminate any potential conflicts. So I'm going to leave that one set to yes. Reset configuration data. When the cards are configured by either the operating system or the motherboard, that configuration information is stored in the CMOS RAM, and that's called configuration data. To change this to a yes, resets that information. Next time you reboot the system, this will automatically be reset to a no, and that information will have been cleared. So this is kind of a one-time setting. If you're having a problem with two cards conflicting and you can't seem to resolve it, try coming in here to reset this configuration data, reboot the system. You'll probably see that the configuration problem or conflict is automatically resolved. And then, of course, this last one here is just whether the num lock, numeric lock key is on or off. I happen to like it to default to off. Most of these settings aren't really that critical or important. That is, even if they were changed from what you had them before, it wouldn't render the system inoperable or it wouldn't prevent it from booting. The only exception to that is the information in the IDE configuration screen. So that's the one I really recommend that you pay attention to and write the settings down at. Of course, it wouldn't hurt to write down all of the settings in here, but that can take a while. Under peripheral configuration, this just controls the configuration of the serial and parallel ports. Normally, it's best to leave these as auto. This motherboard also happens to have built-in sound and a built-in network card, and those are enabled. If you were to install another sound card or a plug-in network card, you want to come in here and disable the built-in one so there would be no conflict. And then this last item here, this one's kind of interesting. Legacy USB support. What does that mean exactly? Well, if you are using a USB keyboard or mouse with an older operating system that doesn't support USB, that's going to be a problem unless you have this enabled. If you have this enabled, it installs USB keyboard and mouse drivers so that the keyboard and mouse will work with older operating systems. And by that I mean anything older than Windows 98. Windows 98 is the first operating system to reliably support USB. So if you're using DOS, for example, and you have a USB keyboard or mouse, you should have this enabled. In most cases, you should probably have this enabled if you are using a USB keyboard or mouse, period, no matter which operating system you're using. Okay. Then over to the next menu here is security. This has to do with password settings. The next menu here is power. This has to do a lot with the power management. That is, will the system suspend itself after a period of time of inactivity or not? You can control those sorts of things here. For example, I currently have the power management disabled. You could enable it and then change the inactivity timer. That's how long it would run before it would go to sleep, etc. You can also have the hard drive suspend. And I'm going to back out of there. What the system's going to do after a power failure, you can have it, return to the last state. In other words, if it was off and the power fails and comes back on, it'll stay off. If it was on, it'll power back on. A lot of times for a network server, for example, you'd want it to be set to last state or power on so that when the power restored, the system would automatically reboot. And then these last 3 settings here have to do with wake on LAN, power management event, and modem ring. And this allows the system to be woken up, basically powered up by, let's say, a network card, a modem, etc. And let's back over out here and go to the boot menu. This is the last menu before exit. And this allows us to change some boot options. Now, quiet boot is interesting. With a lot of systems, when you turn them on, you get some kind of a fancy logo for the manufacturer. In fact, this being an Intel motherboard, a great big Intel logo came up when you first turned it on. Well, I turned that off by disabling, or by enabling quiet boot. You can turn that off. By disabling it, as it is here, you'll see the logos when you turn the system on. Now, that may be if you bought a Dell, for example, you'll see a big Dell logo or a big Gateway logo. These things can also be burned into the motherboard ROM. That's called the user flash area. Using the appropriate software that is available for this motherboard, I can actually burn my own company's logo into the ROM and have it appear when I turn the system on. That's what a lot of the smaller system builders do, and even some of the bigger ones. Dell and Gateway, for example, use Intel motherboards just like this one here, and the only difference between them and you in building their system is they take the time to burn their own logo into the motherboard ROM. So when you turn it on, you see their logo. But anybody can do that. And then this rapid BIOS boot, we mentioned that before. That's the 7 seconds from power on to boot up. If you disable that, then the system will go through a much longer memory test and probably take longer than 7 seconds to boot up. Down here you can also set boot device priority. This means what order the items will be checked to boot from. In my case, I listed CD-ROM before hard drive. Most people would probably have the floppy drive, hard drive second, and then CD-ROM, and then, for example, a network boot device or any other boot device. I changed it because I intentionally wanted to boot off of a CD-ROM to install Windows 98 or a newer operating system. Most of the newer OSs come on a bootable CD, so you can boot directly from the CD with no floppy and then install that way. I'm going to hit escape to get out of here. Hard disk drives, if you had multiple hard drives, you could change their boot sequence without actually having to swap them on the cable. A lot of the newer motherboard ROMs allow this. Older ones do not. In that case, you might have to actually physically move the drives around if you wanted to make like the second drive, your first drive. In this system, I wouldn't have to do that. I'm going to back out. And finally, on the exit menu, saving changes, discarding changes, or we can have various, default setup options. So, I hope this, has been somewhat enlightening. You've seen some of the options in a modern motherboard. What we're going to do next is take a look at the ROM chip from the perspective of not what software is in the chip, but the chip itself, what types of different ROM chips there are, and how you can program new software into your newer motherboard ROM chips.